Hey guys, Miss Malone here. Sorry for the late video, but I still was going to do a video of particular questions that we may still be confused about Unit 2 for your upcoming unit test. I was reading through people's index cards from today, and there were a lot of these similar concepts that are confusing. I will do my best to tackle each and every one. One of the concerns I've seen so far is finding the magic number. So we're going to do that first. Now I'm going to show you how to find the magic number in 3 different ways though. We're going to do finding the magic number on a graph, on a table, and in an equation. And we've done something similar before on this. So let's get started. So if I'm giving you, I'm going to use my workbook for the time being from time to time. So in looking at question number 1, if I need to find the magic number, so if I need to find K from a table, you need to understand that in order to find K, you need that other little formula, which is called Y over X. This is another concept that a lot of students was also asking about, how to know which one is left, X or Y. How do I know to divide Y by X? I always tell you guys, make sure it makes sense to you. So when I'm looking at my values on the left column and your values on the right column, you have to think about it as the left being your X and your right being your Y. And again, unless they use different letters, that was another concept people was getting confused on. So when I try to find the COP magic number, you have to remember Y over X. Meaning, all of the values here has to be divided by the number of values here. So we're talking about money over hours. Again, you got to make sure it makes sense. I want to know how much money in 1 hour. Okay, not how many hours that makes $1. That just doesn't make sense. So I can pick any one of these. I can pick 36 over 3, either one. So I'm going to do the 72 and 6. 72 is my income. That's my money. Over your X value, we're going to represent that as your hours. And 72 divided by 6 is 12. Now, I could have used either one and still get 12, okay? So, finding my magic number on a table, you need to use Y over X. Okay. If I give it to you as an equation, usually finding the magic number on an equation is the easiest thing ever. Okay, as long as your equation is in this form, Y equals K times X, the number in front of X is your magic number. That's just simple as that. So let me look at this. Y equals 11X. Y equals 11X. Now, typically we don't see the multiplication symbol, but this is implying that I'm multiplying because we don't see a plus sign. I don't see a minus sign. I don't even see it written as a fraction for a division. So obviously this is multiplication. And the fact that the coefficient, the number in front of X, stands in on the front, that lets you know that is your magic number. So K for this problem is 11. That's how you find an equation from an, not an equation, find the magic number from an equation standpoint. Now, what if I give you a graph? So if I give it to you in a graph, and I say, okay, I want my magic number. So this represents shirts. This represents your cost. Okay. And then let's see, we're going to do 1, 2, 3, 4, 5. 3, 6, 9, 12, 15. So we're going to plot this point, and this point, and this point, and then we're going to just draw my line. So when I need to find K on a graph, it is no different than finding the magic number on a table. Same, different thing, because you still need to use y over x. So in a scenario of a graph, you can pick any point on the line. For instance, this is 1, 6, or you can use 2, 12. Now, oftentimes, your magic number, your COP, or your unit rate, remember they mean the same thing. Usually if it's an order pair, your magic number is the value in which x has to be a 1. Your y coordinate gives you that magic number. So when I look at this order pair, because I have a value of 1 as is x, that means 6 has to be your k. So 6 is your magic number. Now, what if I didn't have a perfect unit rate number such as this pair, right? What if I was given 212? Okay, sure. This is still x, this is still y. I still need to use y divided by x. So y is 12 and x is 2. You should still get the same value for your magic number. Okay? I want to show you guys a bit. This is how you find the magic number from a table. This is how you find a magic number in an equation. Remember, it's just a number. And then this is how you find the magic number of a graph. Okay. Some students was telling me that they were struggling a little bit on graphs. Now, it wasn't as specific, but I could try to find a way to do graphs just in general. Now, in graphs, I've already shown you how to find the magic number, but I can show you on a graph how to read the graph in words. So, if I am given a graph, I'm going to see if I can draw a graph. When you're given a graph, you need to remember, not always is your scenario a perfect unit rate point. You're usually not given the point sometimes. Okay, oftentimes you're given just a straight line, a random point on that line, and then you need to interpret that. Most of the time, that's how that works. Trying to find us a question. So, oops. If I give you a graph, this represents hours, this represents your cost. And I'm giving you a straight line. So let's say I give you this point right here. This point. This order pair is written as 4, comma 60. And I want you to interpret. How do I explain this in words? Well, usually, unless it is a unit rate problem, you want to try to avoid using per one of something. Okay? So basically how you write it out to interpret this, usually it's written in the form of your Y value. So whatever your Y value is. So in this case, your income or your cost. And this could be a random scenario. It could be like earnings of a job. Okay. It could be whatever the amount of money for every, or you could say for each. And actually, I take it back. You have to be careful using the word every or the word per or each, because that, again, that talks about unit rate. So the Y value for whatever the X value is. Now again, this could be somebody's wages, right? So if I interpret this, I can read it as the working 4 hours. So working 4 hours. And I'm doing this backwards a little bit. Because you can write this many ways. I'm going to show you one way. Working 4 hours gives a total, I use the word total, of $60. So we can say your X gives you whatever your Y value is. You can say it as you can make $60 for working 4 hours. It could work either way. As long as you know how to interpret it, you can interpret it Y first before X and then or X before Y. It doesn't really matter. As long as you know what this means, X represented hours and your Y represented your cost. Okay? Okay. Now, I've already shown you guys on a graph how to find the magic number. What if I give you a graph and I need an equation from that graph? So this is laps, this is minutes. And again, and I'm going to explain about what makes a graph proportional. I'm not there yet. I'm just going to do this one example and I'm going to show you what I mean by graph. When you're given a graph, here's your laps, here's your minutes, but I want an equation describing this scenario. You need to keep track. Your equation still has to look like y equals kx, meaning you need to find k. Well, how do you find k again on a graph? Y divided by x. I could pick either point on here. I don't really care. The easiest one is whenever your point has an x coordinate of a 1. That usually helps out the most. So when x is 1, your y value is 3. So I'm going to do 3 over 1. Well, 3 divided by 1 does give you 3. So, being that 3 is the magic number, the equation that best describes this scenario would have been y equals 3x. Okay. Now, as a reminder for your graphs, What makes a graph proportional? Remember, there are two scenarios. One, it has to be a straight line. It cannot be a curved line. It cannot be jagged and broken up. It needs to be a straight, solid line. And scenario two, it has to pass through the origin at 0, 0. It cannot pass on like 0, 2 or 0, 4. It has to go through 0, 0. That's the origin. So, if I give you an equation like this, and I ask you, is this proportional? Well, first off, is it a straight line? Yes. Does it pass through the origin? Yes, right here. So this is a proportional relationship. But if I give you a problem and it's like this, well, yes, it's a straight line, but it doesn't go through the origin. It's all the way up here. It doesn't start down here. So because that condition is not met, this is not proportional at all. Okay? So I need you guys to also be careful with graphs. That's how you read it when determining what makes it proportional or what doesn't make it proportional. Okay. I'm going to try to go through some of you guys' stuff. Some of you guys are saying tables. Some of you guys are talking about comparing. And some of you guys talk about unit rate. Now, I will go over unit rate in a sense that if I was given a word problem, for a word problem, I would ask you, how do you write it as a unit rate? Meaning my magic number. Means the same thing as your COP. Okay. I'm going to try to blend it because someone also had problems with fractions. So, I'm going to do a few examples on unit rates. Okay. So, Jan used 12 cups of sugar to make 6 pies. So 12 cups of sugar to make 6 pies. But the question is, how many cups of sugar to use for 1 pie? So that means I need to find your cups of sugar per 1 pie. Because I only know how many sugar for 6 pies. I don't know how many for 1. Okay, so first off, you need to know if I have 6 pies, but I want to find the amount for 1 pie. This number cannot be bigger than 12. Let's just put that on a line. So that's why there's no way you should be multiplying these numbers to get the amount of cups for 1 pie. Okay, I only have it for 6. So in order to find per 1, this per means I'm dividing. You're going to take 12 divided by 6. So 12 divided by 6 does give me 2. So what is my unit rate in cups per pie? That means I need to use 2 cups of sugar per pie. You don't even need to use the 1 anymore because I know this is a singular word for pie. I'm only going to write the word pie. Okay. Patty finished 16 math problems in 2/3 of an hour. Okay. So 16 problems in 2/3 of an hour. And I'm putting this together with somebody who was struggling with fractions, they said, with unit rate or COP. So this is a mix and match. So at this rate, meaning this needs to be written as a rate, how many problems can she complete in 1 full hour? Right? First off, this is not even a full hour, okay? So I want to know how many problems per 1 hour. So if you write it in words first, then it is guaranteed on how to put it as a fraction. So problems goes on top. So I got 16 over 2/3. Now, you would use a calculator. You can use Desmos. You can type in 16 divided by, hit the fraction button, and then type 2/3. Okay, because we're going to jump into something later on in Unit 5 where we are translating this by changing division here, because we don't ever divide fractions. So Desmos can do it for us. Okay. So if you use the calculator, 16 divided by 2/3, you would get a whole number of 24. So your answer as a unit rate, because the value is 1, that's where the unit word comes from, that means Patty can complete 24 math problems per hour. I apologize in the background. My cat wants to meow every time I make a video. Okay. That is how you worry about doing, finding a unit rate. Finding a unit rate. Let's see what else I can do. Yep. So somebody write unit rates. Tables was one that people were struggling with. So let's do tables. Yeah, tables. Yep, I've seen a few with tables. Okay. With a table, this one takes a little bit more time. So when you're given a table, typically it tells you either X or Y. Whatever your values here and your values here. Oftentimes we are given a table of values and we need to fill in the blanks. Sometimes we're given a table, we need to know if it's proportional. So I'm going to do the first one. Let's do this. I give you a table of values and we're going to determine if yes, it is proportional or no, it is not. Now, in order for it to be proportional, each ratio has to be equivalent. So meaning they have to be the same. Each and every single time. Now, this is where you have to use your Y over X rule to test it out. So this is more like trial and error. So all of my values here are going to be divided by all of my values here. So we're going to do 8 divided by 2. 16 divided by 4. 24 divided by 6. Now, 8 divided by 2 is 4. 16 divided by 4 is 4. 24 divided by 6 is 4. If you notice that the pattern, all of my values became 4, that means there is a pattern. That means all of my values of X is being multiplied by 4 to give me the values of Y. So, yes, this is proportional. Okay? Now, oftentimes when they ask you to determine, you do need to test every single points, all the points, just to verify that they're the same. Okay? So let's do this one. Now, from the jump, if it is proportional or not, right? Let's check. Let's test to see if proportional or not. You still can do Y divided by X. Now, there's an issue with certain numbers when we get into higher math, okay? Technically speaking, you cannot do 1 divided by 0. So that's already a big no. So let me start with 2 over 1. 2 divided by 1, 3 divided by 2, 4 divided by 3. Now, 2 divided by 1 is 2, but 3 divided by 2 is 1.5. 4 divided by 3 is 1.3 repeated. So I didn't get any of the same exact numbers. And again, let alone this one messed it up already. So this table is definitely not proportional. I didn't get the same number every single time. Okay? Now, I'm mixing these two concepts. Again, this is how you can find the magic number. 2 times the number give me that 8. 2 times the number give me 16. 6 times the number gives me 24. Okay? But what if I give you a table of values and I need you to find the missing piece? I'm missing this value here. I don't know what it is. But in order for me to fill that out, you need to find the magic number. You need to use y over x to do that, because 3 times the number has to give me 60, and 9 times the number, the same one, should give me 180, so that when I find it, I can take 6 and multiply by it to fill in the blank. So let's do 60 over 3. Now 60 divided by 3, you get 20. Meaning 20 does not go here. 20 is the pattern you're looking for. 20 is the magic number you have to use. So that means 3 times 20 made 60. That means 9 times 20 made 180. So to fill in the blank, you need to take 6 times 20, and you should have gotten 120. That is how you fill in the tables when you find the magic number. Remember, COP is the number you multiply your quantities to equal out the result of the other column. Okay? So, I'm hoping that's helped you out with tables for some of my students. Now, I did get some kids being confused with variables other than your X and Y. There's several of you guys wrote that out. They were struggling with X's and Y's. So we're going to do some scenarios that is not X and Y. What if they do use a completely different variable, right? And to throw you off. So, okay. Okay. So, I don't see X's and Y's this time, right? I'm using H to represent hours and P to represent pay. Now, you can start off by writing Y equals KX, but you need to understand something. Eventually, you will have to change the Y and the X. So if I were you, if you draw this on your scrap paper, please please write this original formula out and draw your arrows because eventually you're not going to use those letters. Now, this is the tricky part where I'm telling people you need to think about the way they set this up. Now, from a table perspective, every single time your left column will always be written as your X values. Your column on the right should always be represented by your Y values. So you can always use X and Y at first, but eventually change it to H and P. Meaning, Y is usually by itself in the equation. So now let's look at what Y is represented by. It is represented by your pay. Her pay is represented by a different letter though. So you need to use P instead of Y. Okay. For X, let's look at my column. X represents your hours, in which case hours was represented by a different letter instead of X. It was H. So instead of using X, you need to use H. And now you have to find the magic number. And again, going back to your tables, you can pick any value and divide. It's still going to be Y over X. That's why I made you write these on top. Y over X. So I can do 14 divided by 2, 28 divided by 4. I can do 42 divided by 6. You should still get an answer of 7. So what will my equation be? Rather than use Y equals KX, you're now using P equals 7H. Now, I am okay with using X and Y's, but when you're given multiple choice, some people are confused whether H goes by itself or P goes by itself. Label your table X and Y so you know which one is which. Also, it would make more sense for her hourly pay, meaning how much she's getting paid per 1 hour, rather than how many hours she's getting paid $1. Because I never knew a job that'll pay you $1, right? So, it doesn't make sense. This is why sometimes I need to read what the problem is giving you. Okay, the problems will tell you exactly how to write your equation, how to write out which variable goes with Y, which variable goes with X. Okay. Now, one more thing I'm going to go by is comparing. Some of us are having trouble comparing two different things. And so when we're given two different representations of something, that's when we make the mistake. So, there are key words that I did want you guys to understand. Okay? If I'm comparing two people's pay or a graph of somebody's hourly salary and an equation of the salary, it doesn't matter which representations they're being used, okay? But we still can answer it at the same time. The first thing you need to do, no matter what, that you need to absolutely do is find your unit rates. You need to find your unit rates. For instance, let's say Mario and Claire decide, they're going to cut lawns, right? They're going to cut the yard, cut grass. Okay. Mario, his is getting paid by Y equals 12X, where X represents the hours and Y represents his cost. Whereas Claire, hers is a graph model. Her hours is down here. Her cost is on the side. The question is, who gets paid more? So, question is, who gets paid more and by how much? Now, when you look at these keywords, by how much more, how much less, by how much, that means I am comparing. I need to figure out who has the higher money rate, but I want to know how much more did they make than the other person. Okay? Now, I'm going to put M for Mario, C for Claire. For Mario, his is easy to find my hourly rate. He makes whatever the coefficient is in front of the X in a formula. And again, we've done this before. In this case, it's $12. So he makes $12 per hour. That's his pay rate. Claire's pay rate is on the graph though. And remember, when X is 1, your magic number is the Y value. So because this is 1, this is the magic number. So for Claire, her pay rate is $15 an hour. So now compare. Who gets paid more? According to my numbers, 15 is bigger than 12. So Claire makes more. Now I know Claire makes more, but I need to know how much more than Mario. And one way to work this out is to subtract. Every time you see this phrase, how much more, how much less, by how much, you need to subtract. So I'm going to take 15 minus 12. You should get 3. So if I answer this question, I will say, Claire gets paid more by $3 per hour. I got the 3 from subtracting their unit rates. So when you're talking about comparing two people or two representations, and we're comparing who makes more, who makes less, what's cheaper, what's more expensive, you need to do this in 3 parts. You need to find the magic number, that's 1. You need to find the magic of the other person, that's 2. And you need to subtract to find the difference between them. That's part 3. So these kinds of questions does take time, but it does take 2 steps. It does take 2 steps. Okay. Now, trying to figure out, pretty sure I've done most of the concepts for people. Go back to, okay, finding magic number, get it. Okay, we've done that. Finding the number in graphs, we've done that. Your COPs, your tables. Okay. So this video would really be long. Now I'm going to do one more. Now it doesn't have to do with Unit 2, but someone wrote it in here because this is something that is really like a review from previous grade levels. And we're going to do more of them in Unit 5. But because we're dealing with fractions all the time, we're going to practice converting a mixed number to an improper. So, when I have a mixed number, remember, a mixed number is a whole number and a fraction. Mixed number, okay? Because they're mixed up. There is a rule to work this out. So, for sure, whatever your denominator is here, it is going to be the same at the end of the day, okay? still going to be 5. So, to find a numerator, you need to take your denominator and multiply by your whole number. And then you need to add that answer by the numerator. So, 5 times 3 makes 15. 15 plus 2 would make 17. So if I wanted to use Desmos and it doesn't track your mixed number, you can always change it to an improper fraction. So I'm going to do another one. Okay, so 6 1/3. Again, whatever the denominator is, it's going to be the same here. So now I'm going to multiply 6 times 3, which gives me 18. And then I'm going to add 1. 18 plus 1. Okay. We'll do one more. Let's do 2 4/7. So again, your denominator stays the same the entire time. And now I'm going to do 7 times 2, which makes 14. Now, I write these numbers on the side so you don't forget. After you get those numbers, you have to add. Sometimes we can't mentally keep those numbers in our head. So if you want to write it on the side, that lets you know you multiplied, please do so. Then I'm going to take 14 and add 4 to it, which makes 18. Whenever you're dealing with mixed numbers, this is how you change them to improper. So you can use these on the Desmos calculator instead. I think that's all I got so far. Please, please, please study. You can use your foldables for tomorrow's test. Get some rest. And I will see you all tomorrow.